Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of formal charges. What is a formal charge? Well, when you're drawing Lewis structures, you will often need to find, you will always need to find the charge of each individual element. And then after you find each individual element in the structure, then you need to sum them up and make sure that the net charge is the same thing as the sum you found. Okay? If not, it's not a valid Lewis structure. So how do you find the formal charge? Well, it's a formula. Here we have the valence number minus the sum of the number of bonds, okay, plus each individual lone pair electron. So it's each individual bond plus each individual lone pair electron. All right, so let's look at that in action. There's a quick example here. I'll do a few more in my example video, but here we have formaldehyde. It's the simplest of the aldehydes. It's also used for embalming people, and I'm way off topic, so I'm going to stop recording. So here's formaldehyde. If we were to take a look at formaldehyde, the formal charge calculation for the carbon, for instance, the valence number for carbon is going to be 4. If you go to your periodic table and look on the periodic table, it's in the 4th column, so therefore it's 4, and it's going to be minus the number of bonds to that carbon is 1, 2, 3, 4 bonds, and it has 0 valence electrons. My puppies are having nightmares, I'm sorry. 4, then minus 4 gives you a neutral charge. So then if we look at the oxygen, that would be valence of 6. It's in the 6th column of your periodic table. And there's 2 bonds plus 4 individual lone pair electrons. Yes, there's 2 pairs, but there's 4 lone pair electrons. Make sure you make that distinction. And then 6 minus 6 is 0. So we're looking good so far. Now, we only have to do one of the hydrogens because they have the same thing. As long as they are behaving the same way, meaning there's the same number of bonds and the same number of lone pairs, you only have to do the formal charge once. It'll apply to every one of those. So let's say there was another double bonded carbon-oxygen, which is not possible, but for this example, let's say it's happening, then wherever that other carbon double bond oxygen was, it would have a net charge of 0. So hydrogen is 1, and it has 1 bond plus 0 lone pairs. So this is very stable because there's no formal charges, and if you were to do all your rules for Lewis structures, you would see that this is a valid Lewis structure. Okay, so this is just the concept video, so make sure you practice the formal charges. You're going to see it whenever you're doing Lewis structures time and time again, and it'll mean the difference between choosing the right Lewis structure and the wrong Lewis structure. So I hope I've cleared up any confusion you might have. Practice, practice, practice. Thank you, and have a nice day.